Welcome to this session. This session, we are going to solve a problem of differential equation using matrix method. So the question is, solve the initial value problem, d squared x dt squared plus 4 dx dt minus 12x equals to 0, subject to the condition of the initial conditions that when t is 0, the value of x is 0, and when t is 0, the first derivative of x is 8. Now, to solve this equation by matrix method, these are the steps you need to follow. So steps. First, reduce the second order differential equation into a system of first order differential equations. And then number 2, from one above, form the equation x dot equals to ax. So where A is a square matrix, coefficients matrix, and x dot is the set of the first order derivatives. Step 3, find eigenvalues and eigenvalues of A. And then 4, find eigenvectors of A. And then 5, write solutions as x1 of t is given by e raised power lambda 1 t u1, x2 is given by e raised power lambda 2 t u2 etc, where u1, u2 are the eigenvectors. And then number 6, the general solution is x of t c1 x1 plus c2 x2 plus c3 x3 up to plus cn xn. This what I'm listing is just general ways of solving any higher order derivative by matrix method. And lastly, number 7, replace the initial conditions given in 6 to find the specific values of the constants C1, C2, up to Cn. So what I've listed are just general steps to help you carry out a solution of a differential equation by matrix method. Now back to business. Now our problem is given by second derivative of x and then plus 4 dx dt minus 12x equals to 0. X of 0 is 0 and x prime at 0 is 8. So the step 1 was to reduce the higher order derivative into a system of first order differential equations. This is how we do it. So you say let x to be equals to x1. So you are introducing a new variable x1. And the x1 dt to be given by x2. So then now, it means that this differential equation, so dx dt is the same as dx1 dt, which we are calling it x2. Now, d squared x over d t squared is the same as d dt of dx. Remember, when you differentiate, call this one equation 1. When you differentiate the first derivative, you get the second derivative. So which means now that we have called this one, okay, call this expression x1. So immediately what you are calling, what you do is that you replace the variable x by x1, and then when you differentiate x or x1, you get first order derivative, dx1 dt, call it x2. And so this is like saying d dt, you see dx dt is the same as dx1 dt. So where there's dx dt, you replace by x2, or you can replace by dx1 dt. So dx1 dt, which is the same thing as saying d dt of x2. So therefore now we can write as this given equation will be d squared x dt squared can be written as, take this to the right, so we'll have minus 4 dx dt plus 12x. I'm changing nothing, I'm just rewriting, making the second derivative the subject. And you see, by definition, x equals to x1, so the same thing as writing minus 4 dx1 dt plus 12x. x1 because we have said x equals to x1. And you see, definition of second derivative of x with respect to time is the same as dx2 dt from what you have said here. So where there's dx1 dt replaced by x2. So this is dx2 dt equals to minus 4. This one is x2 plus 12x1. So this is the equation 2. So you see now, equation 1, we have first order derivative dx1 dt. Equation 2, we have second order derivative dx2 dt. So therefore now we have dx1 dt can be written as 0x1 plus x2, and then we have dx2 dt is equals to, this can be written as 12x1 minus 4x2. So this is, call this one 3, call this one 4. Now I see this now with the system we have said. This in matrix form, we have dx1 dt, dx2 dt equals 0, 1, 12 minus 4, and then x1, x2. So this equation we have written is what we let, this one is the x dot, and then this the same as a, and then this vector is x. So where our a is 0, 1, 12 minus 4. So next step now we get the eigenvalues of the matrix A. So eigenvalues are obtained by solving A minus lambda I determinant should be 0. So we'll have 0 minus lambda is minus lambda, 1, 12, and then minus 4 minus lambda. Determinant should give us 0. So that this 2 by 2 determinant will be minus lambda into minus 4 minus lambda minus 12 equals to 0. So 4 lambda plus lambda squared minus 12 equals to 0. So lambda squared plus 4 lambda minus 12 equals to 0. And this is a quadratic, so product is minus 12, sum is 4. So two numbers whose product is minus 12, sum 4, they have negative 2 and 6. So this will be written as lambda squared minus 2 lambda plus 6 lambda minus 12 equals to 0. So we do the pairing, lambda into lambda minus 2 plus 6 into lambda minus 2 equals to 0. So lambda minus 2, lambda plus 6 equals to 0. So lambda equals to 2. I can say lambda 1 equals to 2 and lambda 2 equals to minus 6, solving these two equations, two products. So next, eigenvectors. So we start by lambda 1 equals to 2. So because we are dealing with 2 by 2 matrix, so U1 to be U1, U2. So we need to have this equation being satisfied. AU1 equals to lambda 1, U1. So A is 0, 1, 12, minus 4. U1 is U1, U2 equals to lambda 1 is 2, and then U1, U2. So 0 times U1 is 0, 1 times U2 is U2 equals to 2, then 12 U1 minus 4 U2 should give us 2 U1, 2 U2. So for the equality to make sense, so U2 must be 2 U1 and 12 U1 minus 4 U2 equals to 2 U2, which tells us that 12 U1, take this to the right, will be 6 U2. And actually from this same equation, U2 equals to 2 U1. So let U1 to be T, so that this vector U1 is U1, U2, which will be T, and then U2 is 2 U1, so U2 will be 2T. So 2T, and then you can factor out T, 1, 2. So remember this T is any non-zero real number. So when we let T is 1, then we can take our eigenvector to be 1, 2. So x1 of T is usually given by e raised power lambda 1 T U1. So which will be given by e raised power lambda is 2, lambda 1 is 2, so 2T, and then this is 1, 2. And let's quickly go to lambda 2, which was minus 6. So you let the eigenvector to be given by x1, x2. So this is our U2. So expect to have a U2 equals to lambda 2 U2. This is how you solve for eigenvectors, that you need to ensure that eigenvector eigenvalue equation is satisfied. So A for this matrix, for this case is 0, 1, 12, minus 4. And then we have said U2 to be x1, x2. Lambda 2 is minus 6. And then we have x1, x2. 0 by x1 is 0, so we'll have x2, and then 12x1 minus 4x2 should give us negative 6x1 and then negative 6x2. And so for equality to make sense, x2 should be negative 6x1, for this one, equation 1, and 12x1 minus 4x2 equals to minus 6x2. So which means 12x1 equals to minus 2x2, and you still get x2 to be minus 6x1 for this equation 2. So we can either use 1 and 2 to solve this system. So when we let x1 to be t, then x2 will be minus 6t, because x2 is minus 6x1. So that u2, which is x1, x2, will be x1 you put t, x2 you put minus 6t, which will be 1 minus 6 times t. And if you let t to be 1, then you say that u2 is 1 minus 6. And since x2 is given by e raised power lambda 2 t ut u2, this will be equals to e raised power minus 6 t, and then you multiply by 1 minus 6. So I have gotten the eigenvalues, eigenvectors, and the solutions x1 and x2. Now, by superposition principle, the general solution is given by x of t equals to c1 x1 of t plus c2 x2 of t. So which will be now, because we have already gotten everything, so we'll have c1 x1 was e raised power 2t into 1, 2. That was what we got as our x1, e raised power 2t, 1, 2. And then plus c2 e raised power minus 6t into 1 minus 6. So this is what we call the general solution. So had we not been given the initial conditions, x0 equals to 0 and x prime 0 equals to 8, then we stop here. But then we go further to get the solution. So we are told that x of 0 is 0, x prime of 0 is 8. So this is just the same as saying x, when you put so since we have transformed our equation in the form x dot equals to ax, then this initial condition is like saying x at 0 is given by x prime at 0 is given by, or x dot at 0 is given by 8, and then x prime. Okay, in short, from what we have, with these initial conditions, we can write them as, we had a problem, x dot equals to ax, and then we say x0 is given by the vector, so 0, then 8. So the first line is the x value, and then the second line is the derivative at 0. So when you put 0, we'll have c1 e raised power 2 times 0, and then 1, 2 plus c2 e power minus 6, 0, 1 minus 6 should give us 0, 8. And I hope you should be able to see that what's happening here is that in this value here is like we have C1 into e raised power 2t and then 2 e raised power 2t. This other one we have C2 into e raised power minus 6t and then minus 6 e raised power minus 6t. So that's why you say this value, the derivative of what is above it, this value, when you differentiate, you get this one here. So that's why I wrote the initial conditions as x0, then 0, and then 8. What we have above is the value of the function at 0. Below is the value of the function, derivative of the function at t equals to 0. So then, e raised power, this would be 0. This is also, this e raised power 0 is 1. E raised power 0 is 1. So just have C1, 1, 2 plus C2, 1 minus 6 equals to 0, 8. So I'll have C1, 2C1 plus C2 minus 6C2 equals to 0, 8. Now we'll have C1 plus C2, 2C1 minus 6C2 equals to 0, 8. For these equations to make, for this equality to make sense, C1 plus C2 must be 0, and 2C1 minus 6C2 should be 8. You see, this is call it 1, or this one 2. These are just simultaneous equations in C1 and C2. So from 1, C1 equals to minus C2. When I replace into the second equation, I have 2 into minus C2 minus 6C2 equals to 8. So minus 2C2 minus 6C2 equals to 8. So this means minus 8C2 equals to 8. So C2 is minus 1. And so C1 should be 1. So hence the solution is x of t. We have found out that C1 is 1 and C2 is minus 1. So just replace the values here. So we'll have this one is 1, this one is minus 1. So solution will be x of t equals to e raised power 2t into 1, 2 minus e raised power minus 6t into 1 minus 6. And see, this can be written as x of t is given by e raised power 2t minus e raised power minus 6t 2 e raised power 2t plus 6 e raised power 2t. Now, if you observe what we have done at this point here, when you are trying to rewrite the initial conditions in terms of this vector, this is usually the function, and what's below it is the derivative value. So therefore, in this solution here, this, and you can even see, check it from the structure, this is the function, and then this is the derivative. So therefore, the solution of the differential equation is x of t is given by e raised power 2t minus e raised power minus 6t. You pick what is in the first line. And so that is the solution. And if you are to find the derivative, then what is below is the derivative. So by this is the solution to the differential equation. Thank you.